Hello. Right, today I'm going to try and explain the basic concepts of off-grid power generation. This is going to be, there's a lot to get through, but it's basically the information I wish someone had told me when I started out with this lifestyle. So here we go then. And I'm also going to try not to get too bogged down in technical language. I'm going to try and talk in a sort of more illustrating style, if you like. So when I talk about a battery being full, I don't literally mean it's full of electricity. There is no electricity in a battery in the same way there's no fire in a log. There's the potential for electricity. Anyway, hopefully it'll all become clear. This is the most basic setup then. We've got a panel directly onto a battery. Now this works, and it only works because the panel is so small compared to the battery. So the panel can put out just over an amp at its best in direct sunlight under optimum conditions, etc. Now this is quite a hefty truck battery and that can cope with that. But if I had something like panels on the roof hooked straight up to this battery, it would boil it dry quite quick. So to mitigate that, use one of these. You're going to have to use your imagination a little bit here. So now imagine that the panel goes through the solar controller to the battery. The main function of the solar controller is to limit the panel. I mean, you often think of solar controllers as being kind of like battery chargers in that they charge a battery, but they don't. The main function is to stop it overcharging the battery. There's two basic types of solar controller. There's you can think of the cheap type and the expensive type, but the one that always used to be used and the cheapest one now is called a pulse width modulation controller, and all that means is that it switches. So that's literally what pulse width modulation means. It means switching in and out. The easiest way to think of pulse width modulation is as in an LED head torch, which has a power setting for full power and half power. Now when you put it at half power, it doesn't chop out half the batteries or anything like that. All it does is it switches the light on and off very, very quickly. And if it's on 50% of the time and off 50% of the time, then it's going to be half bright to our perception. We can't see the fact that it's chopping on and off. And that's what the pulse width modulation solar controller does as well. So as the battery starts filling up, if you like, then the controller will start cutting the current in and out, and it will keep doing that until the battery is full, and then it will switch to a float and it will just give it a trickle charge. The trickle charge is pretty much all this panel can manage into this battery, which is why it's safe without one of these controllers. The more expensive and much more effective type of controller works in a different way, and that's called a maximum power point tracking controller. And what that does is it takes the panel at its optimum voltage. So these panels can work at anything. This one here is a nominal 12 volt panel, which means it can work anything from 12 volts up to like 18. So 18 would be its happiest, if you like, under certain conditions. The maximum power point tracking controllers are able to take that power coming at whatever is the optimum voltage and then convert it to whatever is the optimum for the battery. So it's basically a DC to DC converter, and it has a microprocessor in there, and it very quickly calculates all the time what the optimum power is coming in and going out for both the panels and for the battery. So it's a clever bit of kit, much more expensive than a basic controller. People generally say it gives you 30% more efficiency on your panels, and I found that to be the case. There's overcast days when the maximum power point controller that I've got in there is still working like the clappers, and the other one has given up. There's a lot more technical detail on that, but that is the gist of it. So we've gone from the basic without a controller to now we've got a controller in the loop. Now we need to think about getting some power out of the battery to do something useful with, like powering a light bulb or charging your phone or running a fridge or a power saw, whatever it is. So obviously if you just want some 12 volt power, if you've got some 12 volt LEDs, most of the lighting in the barn here is 12 volt, or if you're powering a pump, like there's one going at the moment to power the washing machine, that can run straight off the battery, that can run off 12 volt quite happily. But if you want mains, if you want 240 or 230, whatever it is now, if you want AC power coming off of this battery, you're going to need one of these, an inverter. Again, you're going to have to use your imagination a bit. So we'll put the inverter in the loop. So the inverter connects to the battery, and then whatever you want to plug into the inverter connects to that. So the inverter will take 12 volt, or in my case in there 24 volt, whatever it's coming in at DC, so direct current from the battery, and then it will convert that into mains power. As with the solar controller, there are two types of inverters. There's the expensive one and the cheap one. If you think of, now I don't want to get too bogged down in technical explanations here, but essentially a nice mains power that you would get from a house, if you drew it on a graph, would be a sine wave like that. So it's gently going from 0, and then it's going to minus 240, and then it's going up to plus 240, and so on. And it's doing that in a nice wave. The way a cheap inverter works to try and replicate that is to switch on to 240, and then off, and then backwards to minus 240, and then on, and then so forth like that. And if you plotted that out, it would be what's called a square wave. And you don't really get those anymore. What you get now is a modified square wave. So that's a cheap inverter will be something similar to that. It won't be quite as bad as on and off like that, but it's not a smooth sine wave. The more expensive inverter switches on and off in a more sophisticated way, let's say, and then it replicates much closer to that nice sine wave. What does that mean in practice? Well, it means that if you take your modified sine wave inverter, your cheap inverter, and you do something like run a central heating pump, like I tried here years ago, it will buzz. You know, it's not happy with it. Certain motors aren't happy with that kind of current coming into them. A washing machine will be unhappy with it as well. Lots of stuff you'll find won't work quite right. So like when you're charging a cordless drill off a modified sine wave inverter, the charger will get hot and the battery won't be fully charged. There's lots of quirky things like that. Generally in the long run much better, I've found, to go for a proper sine wave inverter. And there's a way of getting a really cheap one as well, and that's what I did for years before I got the super expensive one that's in there now. And that's to get a computer uninterruptible power supply, and they come with batteries in them, and they're designed to go in offices and such, and you plug your computer into this UPS, and then if you have a power cut, the idea of the UPS, the uninterruptible power supply, is that it gives you about a quarter an hour, 20 minutes in which to shut down your computer without it just dropping dead. They have internal batteries, and when those internal batteries fail, people tend to throw away the UPS. You can pick them up on eBay really cheap, and instead of putting new batteries in, hook them straight up to some proper batteries. And I did that for a while. It's not a very efficient inverter, but it only cost me like 100 quid, and it was able to run a fridge, you know, and everything else I could plug into it quite happily. So that's an option. Again, I'm not dipping too much into detail on any of this stuff, otherwise we'll be here for hours. Right, so we've gone over the basic setups that are available then. What I'll talk about now is the way to charge a lead acid battery, and this is really important. This is something I didn't grasp for a long time. So when I initially moved here, I had a whole load of batteries that I got, I think they were from a mobile phone mast or something like that, but great big fat batteries, and I thought these are brilliant. And I thought what I'll do is I'll charge them up with a massive charger, like once a week. I thought I can charge them up on a Saturday, I can run the generator all day on a Saturday, charge these up, and then over the week I'll be able to use that power. Now that's, if you know anything about electricity and lead acid batteries, you know that's a laughable assumption, but it did kind of make sense to me at the time, because I was not knowing about batteries. I mean, if you had, say, a big tank of water that you were going to use all week, you'd be able to fill that tank of water up on a Saturday, and then all week long you'd be able to use that. I mean, that would work. Batteries are completely different, though, it turns out. So the main point I want to get across about a lead acid battery is when you're charging it, you can get most of the charge in very quickly. So if this battery was flat, I'd be able to charge it up to about 80% within an hour. You can just hook up a giant charger to it, provided you don't overheat the thing, the actual battery, and you don't get it all bubbling away. You can really pack that power in up to about 80% of its capacity. But then getting up to 90-95% will take you about 6 hours, and then that last few percentage will take hours again. And the thing to note here is that that is the case no matter whatever the size of your charger is. So if I've got an enormous, so if I've got a 100 amp charger and I put it on here, and 100 amps is a lot of power, that'll zoom in there, so the battery will just collect all that charge up till it's about 80%, and then to squeeze in that last bit is just going to take hours. So what that means in practice is that if you're running the generator to charge your battery, and you're running a generator for an hour or two each evening, you're never getting it to its full capacity, and then it will start to sulfate inside, and and its effective total capacity will drop. And this is how batteries get damaged, and this is how batteries die after a year or two of use. If you can get your battery up to 100%, and bear in mind that will take 6 to 8 hours to do that, if you can do that every week or two, your battery will last much, much longer. So that's one important thing about batteries. The other really important thing about batteries is to never discharge them more than 50%. So if this battery here was a 110 amp hour, which I think it is, something like that, that would mean I could only discharge it, I could only treat it as if it was a 50 amp hour or so battery. And you have to factor that into your calculations. It is very important to never go below 50% on a deep cycle battery, because again it will sulfate up, it will be damaged, you'll lose the effective capacity, and the thing will be scrapped within a year or two. So how do you know that you're getting near 50%? The only way is to have a smart gauge, and I'll leave it to you to look those up. I tried for years, I thought, well, I know, you can tell by the voltage, the resting voltage of the battery, how much charge is in it, and I can tell by how much ampage is going out. I'll figure it out. I thought, you know, if I could just keep an eye on it, it'll be fine, and it wasn't. It just doesn't work. In my experience, it just doesn't work. And so when I finally stumped up for a smart gauge, and they do cost 130 quid or so, the smart gauge just does what it says on the tin. It just tells you in percentage terms what's in your battery, and it's incredibly useful. So you can tell from that in the morning, you can just check that, and if it says 50%, then you're going to have to put a generator on and pump some power in that battery, and then you can let your solar power do the rest, for instance. So they're the two things to remember about lead acid batteries, is the charge curve. So quickly it'll take a bulk up to 80%, but every now and again you're going to have to put an absorption charge in it, and so people that live on boats tend to do this like once a week. They'll run their generator all day. I found it's really good, even if you've got a little solar panel, you can do your bulk charge first thing in the morning with a generator, and then just let the solar panel do the rest, and that works a treat. It's important as well to have a multi-stage charger when you're charging a lead acid battery, whether it's off a generator or indeed off the mains power. So if you're charging your battery with an old-fashioned car charger, for instance, that's just a transformer that takes 240 AC and it spits out around about 12 up to 14 DC. That will do the bulk charge just fine, but after that the internal resistance of the battery will slow things right down. Even though you're in the absorption phase, which is slow anyway, it'll be even slower because the charger is simply a transformer. It can't do anything about it can't adapt to the changing conditions of the battery. So a multi-stage charger will pump in lots of power at a low voltage, just like a single stage charger. But then when the resistance builds up in the battery, as it gets to that 80% or so, the multi-stage charger will switch to absorption mode, and it will pump the power in at a higher voltage. So a higher voltage is, if you like, more pressure, and it can force in more charge into the battery. So that's a much better way to go. And then when the battery is full or nearly full, it'll then switch back, drop the voltage again, and it will go into the float mode, and it will just keep that battery topped up. An interesting point is that you don't have to have a giant charger for your system, and the big battery chargers are very expensive, but they actually work quite well together. In my system I've got 2 or 3 going at any one time, and they work together happily. And you can use a simple transformer charger as part of the bulk system. So for instance, like a big old forklift charger is great for this, and then you can let your fancy multi-stage thing finish off. So that's what I do in here. I've got multiple chargers on the go, and as the batteries top up, I'll then switch down to just using one multi-stage charger, and I'll run that small multi-stage charger off the little inverter generator. A final point on batteries is that lithium is probably, well, it is going to be the future, but for now it's expensive to use on a small scale off-grid setup like mine. So what I've got is I've got 4 lead acid traction batteries. The type of batteries I've got are the type that you'd have to power a golf buggy, that sort of thing. And with care they should last 7-8 years, something like that. When they're no longer viable, I'm hoping by then the likes of the Tesla Powerwall will have come down in price enough that I can contemplate getting one of those. But for now, for me and for the kind of scale that I'm dealing with, lead acid is still where it's at. So in my case I have a reasonable array of solar, I have a big battery bank, and I have a really good inverter. The reason the inverter is really good, among the reasons, is that it has a huge surge capacity. So that means that I can, for instance, start up my woodworking machinery and it will cope with that. So the inverter is rated at 2000 watts. The table saw I have in there, great big table saw, that's also rated at 2000 watts, but it will take considerably more than that to crank it into life. And the inverter that I have will do that. The cheap Chinese inverters tend to be rated at their absolute peak capacity. So if you get a Chinese one, and I've been through that, and you hook up a table saw to it, if you're lucky it just won't do anything. If you're unlucky it'll pop. And I've been there and done that too. So with a good battery bank and a good inverter, it means that I can run my workshop off of the solar. So what's happening there is I'm running machine tools in there, even up to doing spot welding. Prolonged welding I get the generator out, but even doing a bit of welding I can do with this system. Everything else I can do with it as well, so table saws, pillar drills, sanding machines, the whole works. So what's happening there, even on a day like this where the sun's coming in and out, is that the inverter will just dollop out the power from the battery bank to the machine. If the battery bank is in a high state of charge, some of that power will come straight from the solar. If there's no solar, it'll all come from the battery, and then the solar will then bring the battery back up to 100%. So what happens in the winter then, when there's hardly any solar power? Well, here I found on a really overcast day, my panels in there, up there rather, would, in really overcast conditions, give it about a tenth of what they do normally. Now even that tenth is useful. So if I've got 1500 watts on the roof, 150 watts is still a useful amount of electricity. That's still enough to keep the fridge going if it was going, and even trickle charge the battery bank. So for instance, if it's a really overcast day and I knew it was going to be overcast all day, I would fire up the diesel generator, a big fat diesel generator, and some hefty chargers, and I would do that bulk charge first thing in the morning. So I'd run the generator for an hour in the morning, and then even the little trickle charge that's coming from the overcast skies would be enough to bring the batteries up. So by the evening they'd be near enough 100%. So that way I'm maintaining the health of the batteries, and I'm also never letting them drop below 50 under any circumstances. In the winter, if I'm using the workshop a lot, so if I actually need some power during the day, again what I'll do is get the big generator out, get the diesel generator out first thing in the morning, bring those batteries up. I would also at that point use the washing machine or use power tools or anything like that that uses extra power, because while the generator's running it may as well be doing some extra stuff as well. And then I'd turn it off after an hour, and then I'd switch to something like this. So this little baby thing, this generator is one of the more modern inverter generators, and it's great in its own way. This will produce about 700 watts maximum, whereas my big diesel one produces 4,800 I think. So this thing will just, but this thing is obviously much cheaper to run because it's a tiny little engine, and being an inverter one, it means that it can adjust the engine speed, whereas bigger generators, well, non-inverter generators, have to run at a set engine speed. No matter how much power they're producing, they have to run at that engine speed to spin the alternator at the right speed to make electricity. These ones work in a different way, which means if they've got a light load they can throttle back. So these work as a good backup to solar power, because this thing will run at near tick over and it will just bring that trickle charge in, and it'll only cost you a few pence an hour. It still is costing you, whereas the solar obviously doesn't. But using this battery bank and a decent inverter means again I can use giant power tools running off a piddly little generator like this. Okay, so hopefully that's been useful and slightly illuminating at least. That's pretty much what I wanted to cover. There's two other things I'll just quickly mention. So for summertime use, I found that the solar power not only does everything I need but more, so I've been taking on extra. My mum gave me a bread maker, for God's sake, an actual electric bread maker, and I've been using that to make bread, which is brilliant. Running off the excess power. I mean, if I was running a generator to run a bread maker, that would be daft, but because there's spare capacity, it makes sense. Like I said before, I've got an immersion heater in the hot water tank as well to use up excess solar power, and that saves me having to light the fire. I will put solar thermal panels on at some point. I've got some here. That's another video in itself, I think. So summertime solar, brilliant. Wintertime solar and this thing, and in the mornings a quick blast with the diesel generator. I'm hoping this winter to try and get round to making some kind of wind turbine, just out of interest really. Small wind turbines are not really the way to go, I'd say. I'm just going to make it for entertainment value. Generally, if you've got a wind turbine and it's small and it's not on a tower way up in the air, the turbulence factor around buildings means that it's not really going to work very well. Your other option, and I have done this as well, is a gasifier. So this again is a whole, well, it's not just a video, it'll be a whole series of videos, but in very basic terms, the gasifier I built at least is a charcoal gasifier, and it's basically a tank which holds a load of charcoal bits. And then I smoulder that charcoal. So if you burn charcoal in lots of air, you'll get heat, carbon dioxide and water vapour. If you burn charcoal in a restricted oxygen environment, you'll get heat and water vapour again, but instead of carbon dioxide you get carbon monoxide. Now that's generally a terrible thing if you've got an indoor stove, it's going to kill you. But the advantage of carbon monoxide is that it's flammable, so you can feed that carbon monoxide into an engine and you can run the engine on that instead of propane or petrol or whatever. So you need a spark ignition engine. So I had a military generator here and I hooked it up to this gasifier and I was able to successfully run that. What I do is start it off running on propane off of the bottle, get the engine warmed up, and I'd use the draw from the engine, the suction from the engine, to drag air through the system, get that charcoal smouldering. Then I'd shut the propane off and the thing would run just off charcoal, which is quite it's quite a nice feeling actually, to generate electricity from charcoal that you've made from trees that you've grown in your own woodland. It did take a lot of looking after. It's kind of like running a steam engine in that you've got to keep tinkering with it to keep the thing going. But one day I might pull it back out and have another go at it. Anyway, that's all in the... that's just other stuff. So... right, I think I'll wrap it up there. If there's any more questions on the stuff that I've covered, feel free to ask away. I don't want to get into the business of actually designing systems for people because I haven't got time to do all my own projects, let alone other people's. What I'm trying to do with these videos, as well as most of my videos, is to, well, for one, inspire people to do it for themselves, and for two, to try and give them some of the tools to do it for themselves. So just a push in the right direction. If you can understand the concepts yourself of solar power, for instance, then you can design your own system, and that way you can start small and grow it big, you know, which is what I did. I couldn't have, even if someone had come along and designed me a system, I wouldn't have been able to afford it to begin with. So yeah, I've learned all this stuff the hard way, just by doing it piecemeal over the years. Hopefully this sort of thing can give some of you out there a shortcut to doing it. Right, well, that's about it. Thanks for watching, and I'll see you on the next one. Cheers.